Hello everyone, my name is Kevin, and today we're talking about something related to physics. Have a guess. What would it might be? Okay, this is a hint. It's about a force. Okay, you get it. It's a pull. And when you say a pull, you get it. It's a black hole. So, question 1. We're talking about black holes today is what does a black hole look like? How is it born and how does it work? First, let's tell what does a black hole look like. It looks absolutely like nothing. Just a giant, big, black spot hiding there in the universe. It starts up when a star dies. As you know, when every star dies, it explodes. And it can encounter 3 phenomena. First, the star dies, it explodes, and can never ever be seen again. The next one, it explodes, the bits of dust gather, and finally, a new star is made. And this is the most mortal one. And that's when a star dies, explodes, and turns into a black hole. Scary, right? Okay, now let's tell how does a black hole work and what are the major parts of it. First, let's see its body parts. You can see here in my illustration, this is the shape of a black hole. So you see the dotted lines over here? It's the magnetic field that makes it gravity. That makes it gravitational force. This is the light orbiting around it. Its gravity is so strong, light could even orbit, although the laws of space is nothing could even bend light. And did you see the white dot in the middle here? It's the singularity. And the black part is the event horizon. Okay, so let's imagine it as 3D. Here is the event horizon. Once you pass this dotted line, you can never get back again. And please look at the thin part here. It makes you get through one process called spaghettification, which I'll explain later on. Space is 4D, as you know, and gravity of everything around bends it. For example, you have a 4D net, okay? So a black hole's gravitational pull is so high, it bends 4D space into a very deep hole, kind of like infinite. So let me make you an example. Here's the 4D net. Okay, and here's the sun. The sun only bends down a bit like this in space dimension. But how about a black hole? It has so much gravity that space dimension goes down like this. Now do you understand? And now let's talk about that spaghetti thing that I just talked before. Yum sounds like spaghetti. Just kidding, but it's still related to spaghetti. I mean, what? So what is the difference between a big and black and small black holes? And how is this related to spaghetti? Okay, so as the name suggests, spaghettification is when a black hole squeezes you as thin as a string of spaghetti. Oh my goodness. Now imagine you have a space model of a super huge and super small black hole. Here's the small black hole, and this is the huge black hole. So, as I told you, it bends 4D space. So humans have to pass through spaghettification in this 4D space hole. Small ones could even crush you immediately because they're so small. So kind of like, here's a human. Crush. It's just like getting into the car leftover crushing machine. And how about a big one? You could still survive a supermassive black hole because it doesn't face spaghettification immediately. And it's so huge. That's why. And you can get a chance to get out if you're lucky. Although when I answer the 5th question, you'll never ever want to ride to space again, I think. Or never ever go near a black hole. Okay, so what happens inside a black hole? Well, no one knows. But scientists, by physics, they learned that there is no time in a black hole. And the laws of space always get messed up. What a riot. A black hole's gravity can bend light, like I said, but the law is the opposite. The law is time somewhere would still be the same as at Earth. Yeah, just like if you flew out space 1 month and you come back, it's still 1 month later on Earth. Just like that. But when you get near a black hole, let's have an example. You get near a black hole in kind of like 2015, for example. But when you fly back to Earth, on Earth, it's already in the year 9109. It's just like a time machine that takes you to the future because there's absolutely no time in a black hole, and time is slowed down in it because it has so strong gravity that even time can be bent. So that are the mysteries of the black hole. If you wanted to learn more about space, physics, chemistry, biology, and reading, please subscribe and like for our channel, Soul to Grow. And make sure you visit the channel to see our latest videos. See you!